Good afternoon, YouTube. Hey, good morning, good evening, too. So we're up to part 5 of grade 5 of the hardest math problems. Show your work. All right, so let's jump into this. All right, there we go. There's the first problem. It's a word problem. Like I said, I like these little bullet forms of the way they ask the questions. So what we have is Martin is using unit cubes to build the tower in the shape of a right rectangular prism. That's basically a shoebox on its side. Okay, technically it could also be a cube because a square is a rectangle. Okay, so we got one of those thingies. A description of the tower is listed below. The bottom layer, what do they mean layer? Bottom layer is made of 16 unit cubes. So there's, if we consider that as a unit cube, the bottom layer is 16. So that does not mean we have one, if we were looking at it from the top, 2, 3, 4, that goes up 4 layers. That's 4 layers, 4 levels, right? It's telling us we have basically something like this. If we were to do a 4 by 4. Okay, so we had a 4 by 4, that would be 16 square units, right? Okay, we could also have other scenarios though. We can have a 2 by 8 as the bottom. This is a 2 by 8. This is also has an area of 16. Okay, that was the area of that too. And lastly, we can also have a 1 by 16. And there should be 16 of those in there. Okay, these are all possible scenarios of what the bottom can look like. How do I know that? I took the factors of 16. 1 and 16, 2 and 8. 3 is no good. 4 works. 4 times 4. Since these are equal, there's nowhere to go at this point. These are the 3 factor pairs allowed. Okay. It turns out, though, that doesn't matter. What matters is that they're a layer. Okay. And it tells us, just to reinforce that the bottom layer is in the shape of a square prism. This was a square prism because these are 3-dimensional. Okay, same for here. This dimension here is 1, so that's 1 high. It's 1 high here, and the same thing here. It'll be 1 high. So it's just a flat layer with these orientations I just showed you. Okay? It says 9 more equal layers of unit cubes were added on top of the bottom layer. Well, 9 more, it's 1 plus 9. That means there's 10 layers. Okay, what is the total volume of cubic of the tableau? Well, the volume of a right rectangular prism is equal to the length times the width times the height. We already know that this here is 16, and we're going to go up 10 layers. So whatever the scenario is, 2 by 8 or 4 by 4 or 1 by 16, whatever we're choosing, we're going to multiply that by 10. And we're going to get 160. Okay? And our units are going to be cubed. Units cubed. Cubic units. Same thing. Okay? All right? Some students don't consider this word more, and they end up doing 16 times 9, getting whatever that is, okay? 151, I guess. No, that would be 154 or whatever. It's whatever the answer is there. What is that, 145? 144 is what it is. Okay, some students get that. That is not the answer. Not the answer. Okay, some students don't get any answer because they get bogged down by what exactly do those first two bullets talking about, including they don't know what the shape is, and they don't know how to map this. So there's a lot of terminology in here. You know, you have to just go with what's there, guys. You can't. And this is grade level stuff. This is normally given at the point where all these things have gone over already. So, all right. Some students get bogged down in it, and they end up doing stuff like 16 times 16. And that's equal to 256. You should know your perfect squares like this. Up till 20 by 20, and even a few after that, like 25 by 25. They come up in a lot of these problems, and including in stuff like the Pythagorean theorem, which you're eventually going to have to learn, and stuff like that. Instead of this, because eventually we ended up doing 16 times 10. Some students do 16 plus 10. They get so bogged down with the problem. It's not that. We're looking at the formula, which, by the way, is a requirement for you guys at the grade level. Hold on one second. Let me take this away and show you back the reference sheet that they provide you. Let's see, where is that? Right there. Okay, let me bring that up. I showed this the other day in terms of the unit conversions. I have people's names on the other thing there. So if we look here, this is really the only formula they're telling you need to know. All right, so you can certainly go back to the reference sheet and check that out as well. But this is something you should be familiar with, because them giving you that formula is not really going to help you solve this. I do understand that students freeze up during some exams and so on, but always remain calm and confident, and you should be able to get where you're going. Okay, so let me bring back the problems again for a second. Okay, 2 seconds. Okay, there we go. Okay, so you need to know that formula. If not, it's there. Just for something to grasp on and kind of calm your brain down. It's good that it's at least there. All right, and that's pretty much what's going on here. Also, just to piggyback on this slightly, some students then multiply this by 10 and get 2560. That's getting way carried away. At least they knew there was a third dimension here, okay? But you have to think it through. And again, what I like about these kind of problems is the bullet kind of lets you kind of take each little piece as a bite size. You can often go through it sequentially, linearly, but you don't have to. And there's some questions where you shouldn't be doing that. But it still creates a checklist to make sure, yeah, did I consider this? Did I consider this? Did I consider this? Because one of the things is when we look at these first two bullets, it's easy to get focused on this and not realize that there was this second bullet here. Okay? And what I do is, as I do these, I don't read the whole problem first, because that's going to take too much time on the stream itself. So I just take it each thing as we come across it. But you guys should definitely stop the video every time I come to a question and try to solve it yourself, and then see what my solution is. Speaking of the video, please like and subscribe. And hey, I'm Greg from GregsTutoringNYC at gmail.com. Guys, need tutoring? Hit me up. Okay, so that's 39. By the way, these normally go about an hour. They provided less questions on this sample group of questions, but it's normally from 7 to 10, and I spend, I guess, anywhere from 5 to 15 minutes per question. So this probably will run 45 minutes. Let's see. This one is another one with bullets. Let's see if it helps us. Joel has to practice his clarinet 4.5 hours per week. That's implying total. There's an implicit total there. Or we could put the word total here, or for a total of, right over there. The list below shows the number of hours he practiced so far. Okay? So on Monday it is an hour and a half, Tuesday is an hour and a quarter, Thursday, how many more hours does he need to practice to meet the goal? Again, the goal was the 4.5 hours. Okay? So what we can do is add those up. So we have 1.5 plus 1.25 plus 1 and no fraction. So we need to add that up. So what we're going to do is we need to get common denominators. So we're going to map this into 1 2/4, right? A half is the same as that. 1 1/4 stays the same. And then 1. So we have 2/4 plus 1/4 is 3/4. And 1 2 3 gives us 3 3/4. Okay? The total he's shooting for is 4.5. So now what we have to do is take 4.5, subtract from that 3 3/4. We have the same situation. We're going to map this into using quarters. So this is 4 2/4 minus 3. Whoop, I wrote 3/2. 3 3/4. Okay, let me just stop 1 second. I want to make sure because I don't always get the numbers right. Let's see, 1.5, 1 1/4, 1. That becomes 2/4. That's 3/4, 3/4, 3 3/4. Cool. 4.5 minus 3 3/4. We get 4 2/4 minus 3 3/4. Yes, we're good. Okay, so we can't subtract 3/4 from 2/4. So we have to borrow from the whole number pot. This becomes 3. And we're going to add 4/4 to this. Okay? Why are we adding 4/4? Because any number of itself is 1. We just took the 1 away from the 4 to make it 3. So this becomes another transformation again. 4 6/4 minus 3 3/4. No, sorry, 3. This was the 3 here. Let me actually erase that. I don't even want to cross it out. Right? Let me, right here, I just made that 4 into a 3. So this is 3. Okay, 6/4 minus 3/4 is 3/4. 3 minus 3 is 0. So that's our answer. Our answer is 3/4 of an hour. Okay, hours. Okay, our units are in hours. Okay, do not convert this into how many minutes, guys? What's 3/4 of an hour? Should be 45 minutes. It says how many more hours. It doesn't say minutes. Okay, I suspect on this, where I pulled this from, that you would not lose points for that, but they're asking for something specific here. It's the same when we have the unit conversions of volume, saying meters and kilometers or something. If it says how many kilometers, giving the answers in meters makes no sense. Or giving the answer in miles at that point makes no sense. So they're asking for hours specifically. I'm just adding this in extra, but they're not looking for that, okay? So that's one way to do it. Some of you have different ways of adding mixed numbers and subtracting mixed numbers. This is how I do it. I think it's a good way and often the best way. the alternate is to like only add the whole numbers first and then do the fractions separately. It starts getting too meticulously bogged down with different alternate stuff that you have to eventually drag in together. And if it's just left compact like this, it's usually the best way. I'm not suggesting alternate ways are not working for you. I'm just trying to get you guys to be where it's optimized at some level and that you're doing that, okay? So as always, there's different ways to do a lot of these problems. Some students prefer to map this into minutes. So an hour and a half is 90 minutes, right? 60 plus 30. By the way, before I move away from that, even though the answer here was 3/4, enough students do that subtraction. They don't do, let me change the color of the pen for a second. They don't do this conversion that I did right here, and they subtract at this point the 4.5 minus 3 and 3. In fact, they do it at this point, and they get a half as the answer. Okay, just there's a math illusion there that happens. So be careful, guys. You actually have to do it. Remember to reverse your operations as well. So sometimes if you were to do 3 3/4 plus a half, remember, always check your thing. You might realize, oh wait, that's not 4.5, right? Because that's 2/4. You're going to get 5/4 there and realize, oh, that I messed up there somehow. Well, that should have been 3/2 actually. I just messed up. All right, so anyway, coming back to here, we have 90 minutes. An hour and a quarter on Wednesday is 60 plus 15, that's 75 minutes. And Thursday is an hour, that's 60 minutes. Okay, let me just double check that. An hour 60, an hour and a quarter is 60 plus 15 is 75, and that's 60. So we add those up. 0, 5, 0 gets 5, and then 9 plus 7 is 16. That's 225, and let me do that backwards. 13, yep, 22. Okay, so that's 225 minutes. Practiced so far, okay? He needs to practice 4.5 hours. So we're going to get, this is 240, and this is 30, okay? So that would be 270 minutes. So if you subtract that, 270 minus 225, okay, we get 5 there. And we get 5 there. Okay, that doesn't add up, so I've made a mistake. Let's see. Probably the subtraction right there. No, I actually did the subtraction here wrong. 270 minus 225. I can't take 5 from 0. I have to borrow 1, 5. So we get 45 minutes. That matches up with our 3/4 over here. But we, at this point, we can't, as we discussed already, the answer has to be in hours. So now you eventually have to map that back into 3/4 of an hour. All right. And that's probably the gotcha there. So was it worth converting it into the minutes and back? Maybe. It is nasty doing the mixed fraction conversions, the addition and subtraction. Either way, this is basic operations. And as you saw, I goofed up. What's always cool about goofing up is to realize that you didn't backtrack and figure out where. Okay, and I'm always double checking stuff. And even if I had added this back, if I did the 225 plus the 55, right? I got 501, 5, 6, 7, 8, 280. Wait a second, I started with 270, right? So there's always, you have to do the inverse operations to always check yourself. All right? Okay, so this Uh, so just to be clear about the concepts, this is a geometry problem involving volume of a shape, in particular a right rectangular prism. It involves some multiplication. It involves some spatial knowledge of the shape, things like that. Okay. It involves factorization. Okay, this is pretty much about fractions, about mixed number operations, and if you convert it to the minutes and back, it's about unit conversions as well. Otherwise, it's just about addition, subtraction, orally. Okay, it's indirectly also about time, because you have to know how many hours, how many minutes is in an hour. Okay, I think you all know that. They're both word problems, so you have to be able to figure out how to get through that. That's always a gotcha. And by the way, my throat's going out. I mentioned on the video I posted yesterday that the answer set seems to have been simpler than the other 4 or whatever they had done. This one so far actually even seems simpler. And again, remember there's 200 topics, 200 concepts that they can pull out of their hat to put on to provide to students. And this is kind of where we're at. So it's the luck of the draw which questions you end up getting. All right. So this is a place value question. What is the value of the digit 2? This is not 2, this is 2,000. And how does it compare to the value of the digit 2 here? This is not 2, this is 20,000. Okay, so you actually want to say that it says explain your answer. It doesn't really want you to show the math. But remember, often when an explanation, you have to kind of do that. And you can't say this 2 is in the thousands place and the other 2 is in the 20,000s place. They want you to be precise here. You basically have to mention that the 2 represents 20,000 and that when you do a comparison, that the other 2 represents 2,000 and that 20,000 is greater. You could also flip that. You actually don't have to use this number sentence in your answer, but it would behoove you to do so since it's math, right? You're writing an answer, but you're not just doing this. You're using words. You can explain it out. That you're comparing 20,000 to 2,000 and that the digit 2 mapped into the 20,000 and mapped into the 2,000. All right? This is just place value. It's just simple. This one isn't too bad. You can grok 2 points right there, at least from where I'm getting this from. 42 throws enough students off. I'll admit that. So there are 5 cups of oatmeal in a container. Stella eats 3 cups of oatmeal every day for breakfast. How many days will she finish all? Okay, there are 5 cups of oatmeal. Well, you can run a little experiment. It seems that she eats a third in one day, and a third in the second day, and a third in the third day. That's a group that becomes 1, because there's 3/3 equals 1. So if it takes her 3 days to eat 1 cup, then it should imply that it takes her 5 times 3, because it's 5 cups, equals 15 days. Okay, so to make sure we're looking at days, we're going to peek at the answer thing here, right? So we're at days, and we're cool. We're cool. The answer could be as simple as that if you wanted to. If we don't get so bogged down with the visual of it, we could do it strictly math. We have 5 cups, and we're going to divide that by a third of a cup, right? And that's going to give us the number of pieces. A good way to do some of these is to take these numbers and make them small. So if this is 1, if she had 5 cups and she ate 1 cup a day, everybody knows it's just 5 over 1 equals 5. So remember, do those simple experiments. This was also an experiment, but we can do it over here with raw math as well. So if it's 5 divided by 1, then it's 5 divided by a third. So now we're going to come and take this, and just to keep it strictly math, 5 divided by a third. Division by a fraction is the same as multiplication by its reciprocal. And again, we get the 15 back there. So booyah. Oh yeah, booyah. Okay. Some kids get a little confused in this mapping, and instead they do 5 times 1/3 equals 5/3. That's not it. Okay. Can't do that. Can't do that. Can't do that. On that same note, some students just go for broke, and they do 1/5 over a third equals the 15th. No, we're taking the whole divided by the part, and then we get the number of parts that it took. How many multiples of this part? That's what they're looking for. How many times do we need to do 1/3, right? And if we were to take what I drew here and do a second one, a third one, a fourth one, and this was in 3, and that was in 3, and that was in 3, we'd have 3, 6, 9, 12, and eventually the next 3 gives us 15. We could have counted up once we realized that too. We could have done 3, 6, 9, 12, 15. Honestly though, for grade 5, you shouldn't be doing that anymore. All right? All right? So just start being in tune with the math. All right? What else can we say here? What else can we say here? What else can we say here? That's probably it. So this was testing capacity, because it's dealing with cups. There was no unit conversion, because this was 5 cups and this is 1/3 of a cup. It's dealing with fractions, in particular division by a fraction. And then it's just regular multiplication at that point. This could have been nastier. It could have been 99 cups that had 1/6 of a cup over here. So that would have been nastier multiplication and division, obviously, at that point. But they were testing the concept. This is demonstrative of that they're not giving you bad, complicated numbers to work some of this out. And remember, do your experiment over here or your experiment over here. If you're not sure, test it out and see it works. There's one gotcha, which I've mentioned sometimes in the past. Sometimes using 1 that I said over here can turn out to create identities, mathematical identities, where the answer seems to work out. So usually we should use numbers that are not 0, not 1, and sometimes not 2. And sometimes, even though 10 is a good number, sometimes 10 is a bad number. So try 3, 4, often good numbers. And often, despite what I just said, 10 is often a good number too. Okay? But be careful for identities. So that for that note, it might be worth doing two quick experiments so that you understand what is the operations you're being asked to do here. All right? That was 42. Okay, Olga decorates blankets with ribbon. She has 12 yards of ribbon. She uses 22 feet to decorate blankets. After how many feet remain? So it's 12 yards minus 22 feet equals how many feet? Okay, this is feet, that's yards. So you should all know that 1 yard is 3 feet. So if we do 12 times 3 here, we're going to get 36. So we end up with 36 minus 22 equals what? 14 feet. Okay, you can feed it back in to make sure. 14 plus 22 is 36. 12 times 3 was 36. We got that right. Okay, and just make sure we're using the right numbers. 22 and 12 was the original numbers. Cool, awesome. Okay. My throat's giving out. And I have other sessions today. Oh, man. Okay, the other way to solve this, let me change the color of the pen, was to convert the feet into yards. I'm not quite sure why somebody would do that, because the answer is asking about feet. But let's take the hard way around and see if we get the right answer. It's going to be a little more bumpy than what we just did, but let's go for it. So 12 yards. So we're going to use that, 22 feet. We're going to use that same ratio conversion and multiply that out. So 1 yard is the 3 feet. Okay, this cancels, feet and feet cancel, so we're left with 22 times 1 yard at the top and 3 at the bottom, so that we get 22 thirds. So that's the number of yards we can actually go and do it. Okay, so we can get 3 here. 8 times 3 is 24, so it's going to be 7. 21, so we get 7 1/3 yards. Okay, so 22 feet is 7 1/3 yards. So then if we take the 12, right, and subtract 7 1/3 from that. Okay, you can do that in your head, or we can borrow 1 here, and this becomes 3/3. So 3/3 minus 1/3 is 2/3. And 11 from that is 4. So we get 4 2/3. Okay? Okay, that's after subtracting it. Now it's asking us how many feet. So we still need to convert to 4 2/3 because this was yards, right? We've converted the 22 feet into yards. So we did 12 yards minus 7 1/3 yards is 4 2/3 yards. And by the way, we should double check that. 7 1/3 plus 4 2/3. This is 3/3, and that's 11. 11 plus 3/3 is equal to 12. So that checks out. All right. So we have 4 2/3 feet yards. So we're going to convert that to a top-heavy fraction. We get 12, we get 14 thirds. Okay? We're going to convert yards back into feet, because this was yards. We want to get rid of the yards, so we're going to use the same thing here. But over here, we did 1 yard is to 3 feet. Here, we're going to do 3 feet is to 1 yard. So the yards cancel, the 3's cancel, and we're left with 14. Okay? So we get back the same answer here, and it's in feet. All right, so that's the alternate way to do this. Some students do this 12 times 3 and stop there. That's not the answer. You're not finished yet. Let's see what else kind of seems to go wrong. Some students also get bogged down, and they multiply this by 12 afterwards. Once they get to 36, they're lost in the unit conversion. And I think this way of using a ratio here and a ratio, what I do right here, is a way to kind of make sure you don't do that. Because once you cross off this feet and this feet, you're only left with yards at the top. Many of you are used to doing canceling out numbers. One number divided into the other number. You're canceling out units here as well. So it's kind of a handy-dandy way to kind of do some of this stuff. It's awesome. Yeah. All right. And some students take the 12 and they add 22 to it. That's not it. Some students take to 12 and they multiply it. I want you to do it. That's not it. Take it a sentence at a time. She has a blanket. She has 12 yards. She uses 22 feet. How much is left? Just that. So we have to do that unit conversion. So this is about unit conversions, and that's pretty much the concept. There was definitely a little multiplication here, but not too grandiose. And if you did it this way, mix number subtraction. Okay, and again, the answer is in feet, so that double checks we're kind of on par, on level, in sync with what the problem is. Okay, 44, we saw this in the part 4 one. I don't know what section I did it in, but it says to explain something here. And in the explanation, you have to give the mathematical premise and support. You just can't say 1 and 1 is 2 because it is. All right, so in the expression 5 times y over 7, what is the value of y? What value of y would make a product greater? So you have to answer that and explain why. Okay. So if 5 times y over 7 must be greater than 5, well, if this was 1, if y over 7 was 1, then 5 times 1 is equal to 5. So that means this value here must be greater than 1. All right? So now we're left with, how do we get y over 7 to be greater than 1? Well, if you think it through, any number over itself, so 7 over 7 is equal to 1. So the numerator must be greater than 1. Sorry, 7. Y must be greater than 7. Okay? Once you conclude that, test it. Is 5 times 8 over 7 greater than 5? Well, that becomes 5 times 1 and 1/7. Yeah, because 5 times 1 is greater than 5, so is equal to 5. So 5 times 1 and 1/7 has to be greater. All right? And you can make it something simple like a multiple of 7. So if y was 14, okay, then that's obviously 5 times 2, which definitely is greater than. All right? So there's those ways to do it. I'm going to go and change the color. I'm going to solve this algebraically for any student who's able to do that. This is beyond grade level, but let's go do it. We can solve this as an inequality. So if I do 5 times y over 7 is greater than 5. There's a couple ways to do this, but I like to look at this because it's 5 times y. This is the same as this, 5 over 1. So what I get is 5y over 7 is greater than 5. So to get y by itself, I'm going to multiply both sides by 7/5. That's times 7/5. Okay, these 7s cancel, these 5 cancels, these 5 cancels, and all I'm left with is y is greater than 7. There you go. And you lived happily ever after. So there's some algebra here because it's using a symbol. This involves knowing how identities work. Really, 2 identities. A number times itself is times 1 is equal to the number, and the number over itself is 1. And we need to know that we need to go greater than that. So what we need to do is take some of these things I've drawn here with the words to match that. You just can't do one or the other. You have to do both. That's what they're asking you for. They want to know what y is. Y can be any number greater than 7, and explain why. Okay? It's really not much else going on there. And they're asking for your value. So you could have said 1,000,000, right? There's an infinite number of choices there at that point. But the key is to explain it. Okay? And you have to evaluate it. You have to show them the evaluation, like I did here for this. Okay, like I did here for this. Even in the form here, okay, you just can't show the algebra and say, hey, cool, this is awesome. It's not what they're looking for. They're looking for an actual value for y and the reason why. All right, so even if you gave the algebra, you have to say it could be 10 and give the reason why. Justify it mathematically on top of that. And you can refer back to the algebra. Same on the other way. You can refer back to the logic you used. That's all they're looking for. They're trying to make sure that you understand the mathematical concept. Okay, and this is the last question. A lot of students actually got this right, so this probably won't be too controversial. Diane has pizza dough for making pizzas. Awesome. She separates the dough into 3 portions. Portion A, portion B, and portion C. Okay. Portion A is 8.25 ounces. Okay. Portion B is twice as much as A. So B, if we look at this algebraically, is 2A. Okay. We know that means 2 times 8.25. Okay. Or it means 8.25 plus 8.25. Okay, 16, we get that equals 16.5, no matter how you want to do this. You can do that. If you want, you can put the 0 at the end here, because we notice we may have to do something with this here. That's 2.5 in the hundredths column, and this 5 here is only in the tenths. We don't know if we have to do something there, but let's see. And this is also in ounces. And then C is equal to twice B. Well, if B was 16.5, this is 2 times 16.5. Or 16.5 plus 16.5. And we get 33 ounces there. Okay. Some students goof up this relationship, and they do for C, they do 2A plus just the 1650. So they're getting the wrong answer by doing that. Okay? Take it a step at a time. All right? And build it up. Okay, what is the weight in ounces of portion B and the weight in ounces of portion C? Well, booyah, we got there. Double check. There's no unit conversion. That's in ounces. This is just twice, so that's got to be in ounces. This is twice again. That's got to be in ounces. This was twice A. This was twice B. What is the weight in ounces of portion B and the weight in ounces of portion C? Double check these, because they could have said this may have been in pounds. Okay, they didn't. We're going to come here and peek at what they gave us. B is in ounces. That's there. So this is what, 16.5. And this is 33. All right, so as you guys can see, it was definitely easier. This is probably the fastest one I've done of these, and a couple of dozen of these. In fact, some were so long I had to split them into multiple pieces, although sometimes I did that from a logical perspective because I wanted to split out the algebra examples. I believe this is going to be the last one I'm going to do for grade 5 right now. I'm going to skip to grade 6 after this. And I may eventually come back to all of these at certain points, like hoping to build on these in various ways with different premises and different ways of approaching some of these things. So now we have all multiple choice for grade 3 to 5, grade 3 to 8. We have all show you work for grade 3, grade 4, and grade 5. I'm going to start grade 6, do grade 7, do grade 8. Who knows what I'm going to do after that. I'm also considering ELA, similar examples for ELA problems, passages, and questions, and grammar, and different aspects of that. I'm also thinking of doing it for the Regencies, which is basically high school level classes. All right, so if you're needing tutoring, please check out GregsTutoringNYC at gmail.com and hit me up with a message. If you have any questions about anything covered here, do the same thing. And don't forget to smash the like button. All right, guys? And subscribe.